Okay, so a short one today, guys. I know you're busy getting ready for the acids and bases test, but we've started the redox unit, and so I want to give you a few minutes on some of the definitions here. So if you go to page 2 in your notes, we just finished talking about how oxidation can't happen without reduction, and that together they're called redox. So let's talk a little bit about electrons and redox. So far you've learned that the history is that when things became oxidized, it really meant that they gained oxygens, and when they got reduced, they lost oxygens. But as we talked about in class, just like Arrhenius and Bronsted-Lowry theory, Arrhenius had one theory and Bronsted-Lowry kind of cast a wider net. It turns out that the definition of redox is actually a little broader than originally was thought. So let's take a look here on page 2. As scientists became more familiar with what was actually going on in redox reactions, they realized it wasn't just for oxygen-containing reactions. So this brings us to our first mnemonic for this unit. Now, mnemonic's a really crazy word. It has a silent M, okay? So be thankful that English isn't your second language, because I don't know how people ever figure it out. But just like there are other units that, specialize in worksheets like gas laws did, a worksheet for every gas law, this one specializes in mnemonics, which are kind of like acronyms that are meant to help you learn something. It has to do with our friend Leo the lion. Leo says GER. And so part of your homework is going to be, when you come into class on Monday, you have to growl at me so that I know you did the assignment. Okay, so what does this mean? I'm going to fill this in for you right here. So we're going to do this all together. Leo says GER means that loss of electrons is oxidation. I'm trying to just bold the highlighted letters here. Okay, so L-E-O, Leo. And as you might imagine, gain of electrons is reduction. Now, I warned you about this on Friday. You are not going to like the fact that reduction involved the gaining of something. And it's true, it does. And again, a lot of it has to do with historical reasons, that reduction was thought to be a reduction in the number of oxygens, and it can be. But it turns out that when you lose oxygens, you're actually gaining electrons. And we'll talk about how that all works out as the unit goes on. But what I need you to know from this is that loss of electrons, as soon as you lose electrons, that's called oxidation. As soon as you gain electrons, it is called reduction. So if you go to page 3, we're going to take a look at an example of how this can be worked out. First of all, have we talked at all about losing and gaining electrons this year? I mean, my goodness, we've talked about it since the beginning of the year. So what I want you to write down here is what kinds of elements tend to lose electrons and what types of elements tend to gain electrons. You might need to press pause right here to do that. What kinds of elements lose, what kind of elements gain electrons? And really, we're going to be continuing to talk about losing and gaining electrons now, but just in a different way. So let's look, and you can press pause and fill that in, but right now I'm going to move on here to the reaction of magnesium and sulfur to make magnesium sulfide. So very simply, you can write this if you want, not important. The reaction is very simply Mg plus S goes to MgS. What I want you to do is and this is actually really cool because it's review time in a way. We're going to start talking about bonding a little bit. I want you to draw the dot diagrams for magnesium. So you do the magnesium over here. And you can do the sulfur over here. And I want you to do 2 dot structures. And I want you to try and think about what happens as this reaction occurs. What happens to the electrons from the magnesium? What happens to the electrons from the sulfur? So press pause and write down what happens, which one loses, which one gains. The electrons do move, I'll give you that hint. Now that you've done that, I want you to write down what was oxidized. In other words, going back to this mnemonic, which of the elements lost electrons? And that's what was oxidized. So I want you to write an element here, either Mg or S, and then what is being reduced? Which one gained electrons? The Mg or the S. Once you've done that, I want you to do the whole thing from scratch. I'm not going to help you along this one quite the same way. I want you to do the synthesis of potassium chloride from potassium and chlorine. All you need to worry about is the elements, K and Cl. I want you to write down the dot structures, what happens to the electrons, which one gets oxidized, which one gets reduced. And it kind of feels like charge, because it really is, but we have to make some changes to our definitions, and that's for a little bit later. But right now, I just want you to see the application of oxidation and reduction and the use of Leo says GER in order to figure out what's getting oxidized and what's getting reduced. Okay, so that's it. Told you to be short. Thanks.